Hey guys, welcome to my channel Emulation Nerd, and today I will try to make this video as short and precise as possible. So the topic which I chose for today's discussion is Master's Theorem, and it is somewhat related to divide and conquer algorithm which we discussed in the last discussion. So if you haven't been to that video, I will be describing the link to that video in the description below. So without talking anything else, let's just dive in into the discussion straight. So talking about Master's theorem. Master's theorem helps in the asymptotic analysis of recurrence relations that we generate in divide and conquer algorithm. So yeah, so diving straight into the concepts of Master's theorem, here is what it says. Suppose there is a relation Tn with some sort of generalized work n by b, considering the fraction to be the upper bound plus big O of n to the power d. If you guys can remember, we generated this sort of total amount of work that needs to be done during the analysis of divide and conquer algorithm which we discussed. So yeah, and for the constants for this, a should be greater than 0, b should be greater than 1, and d greater than equal to 0. So if such relation exists, which is very common to have in divide and conquer algorithm, so this is the generic formula. Total work done would be big O of n to the power d if d greater than log a with base b, and the second situation will be big O of n to the power d log n, such that d is equal to log of a with base b, and the third situation would be d is less than log of a with base b. So the formula in that situation derived would be n log of b a with base b, such that d is less than log of a with base b. So this is the general format of Master's theorem. So in the previous video about the discussion of the Master's theorem, we just calculated in more mathematical way how to find the total amount of work in order to calculate the time complexity. So you can just prevent those mathematical calculations and straight away dive into this master theorem in order to have the time complexity of the algorithm you just generated. So yeah, so before moving onward, we will look into some examples. Suppose for the first example, let's take the example of polynomial multiplication we used in the previous video. So the work needs to be done or generated there was Tn equals to 4 times T n by 2 plus PO of n. So in this case, this will be A, this will be B, and since it is n, so it is of the power 1, so this will be D. So here in this situation, log to the base B will be 2 and A will be 4 equals 2. So in this situation, B is less than log A with base B. So the formula we will use here is what we call big O of n to the power log A with base B. So times what is required will be somewhat big O of n, and the log is log 2 with 4. As we saw that the value of A is 4 and the value of B is 2, so log of 4 with base 2, so it becomes the big O n square. This is exactly the same complexity which we did used in the previous video about the polynomial multiplication. Now considering for the binary search as a second example, the total amount of work that needs to be done will be somewhat time of n by 2 plus before I'll leave this thing up to you in order to calculate the total amount of work needs to be done in case of binary search. So this is for binary search. So just deduce this equation from in the way we did in the divide and conquer algorithms video, and you will get somewhat this equation. So in this case, since it is 1, so A will be 1, B will be 2, and it is somewhat like D will be 0 because its value is 1, so D will be 0, because in case we have any number x and if it is power of 0, it has power of 0, it will get reduced to 1. So it doesn't matter what the value of x is here, we are only consider about the power which it has or the value of n, which we say. log b, log of a with base b becomes log of 2 with 1, and it is equal to 0. So in this situation d is equal to log of a with base b. So the formula which we will have is big O of n log big O of n to the power d times log of n with base b. So the total time will be big O of n to the power d times log a with base b. So what it gets reduced to is somewhat big O of n, d is somewhat 0, log of 2 with log of 1 with base 2. So sorry, it is log of n. I just noticed that I misspelled it as log of b2. So we need to replace it here. It is log of n. So it gets reduced to somewhat big O of n. So this is the actual time complexity of the binary search as well. Well, this is all about the master's theorem. So this is all about the divide and conquer algorithm, which is used in that asymptotic analysis of the recurrence relations in divide and conquer algorithm, which we used to derive in divide and conquer algorithm. And for your reference, I will be attaching the link to the divide and conquer video and in the description below. So if you haven't understood anything, or if there is any sort of confusion regarding the master's theorem, please do comment down in the comment box, and I will surely reach out or make a separate video regarding that. So just stay tuned. Please do like, comment, share and subscribe, as well as press the bell icon so that you never miss the any new video. So see you then in the next video. Bye.